Hello, everyone. Welcome to Visma Talk number 70. We have a really good one for you today, but before we get to it, some housekeeping. If you are curious about the upcoming schedule for future Visma Talks, you can go to the Visma Talks page on Confluence. Just search for Visma Talks and you'll find the upcoming scheduled talks. And on the same page, you can find previous recordings and slides from previous sessions as well. I'm always looking for potential future talks. So if you or you know someone who should be in this forum at a later point and give a talk that other colleagues of ours will appreciate, let me know so we can put them on the schedule. If you have any questions during today's talk, you can go to the Visma Slack and go to the Visma Talks channel in that Slack. If you ask any questions there, we might get to them at the end of today's talk. All right. I met today's speaker at the DevOps conference not too long ago. Mike Long is the CEO of Merkely and has been a recurring speaker at DevOps Days several times, which is also today's topic. So without further ado, I'll give the word over to you, Mike.
Super, thanks, Alexander. Hi, everyone. So like Alexander says, my name's Mike. I'm the CEO of a company called Merkely. We're not going to talk about Merkely today, but just a little bit of background about me. So I'm a technologist. I studied computer science. I spent 10 years in oil and gas industry, commercializing deep tech. So my background is more or less in quite systems programming, I would say. Kernels, device drivers, networking, file systems, real-time systems. So I worked in projects in UK and Norway and China. And after 10 years of that, I needed change. But even from a student, I was always interested in the craft of software, how software gets made. You know, back then, the new thing was extreme programming. So I was quite interested in test-driven development, things that came later, like continuous integration, continuous testing, all these areas that ended up being part of what we call DevOps these days. So after 10 years in that field, I moved back to Norway and joined forces with a couple of Danish entrepreneurs, and we built a DevOps consulting business together. And I was the CTO in that business. So over 5 years, we grew the company to 50 people, 7 offices in different cities in Scandinavia. It was a lot of fun. And, you know, I got exposed to a lot of different challenges and a lot of what would essentially these days be called digital transformation projects, how to make change in the way organizations deliver technology. And that's why I was also very, very interested in what Alex had to share at DevOps Days as well. I think what the journey you guys have been on is super interesting. I'd love to dig more into that at some point. Anyway, a couple of years ago, our company was acquired, and I already knew that I wanted to do something in this DevOps compliance and traceability space. You call it metrics, compliance, security. But I've been working on this for a couple of years, but still very much interested in the space of DevOps and the community around DevOps, the culture of DevOps. And that's what this talk is really about. It's about how, well, what is DevOps really? What's it for? And what does it mean for technical organizations? So I hope some of this will be relevant for you guys. Now, as Alexander said, this was a conference presentation. Usually these things tend to be more interactive. I would love it if you have questions that you do write them down in the Slack so that we can take them at the end. It's a lot more fun if we're all involved, I think. Anyway, without further ado, I'll bring up some slides and we'll get underway. Just to confirm, Alex, can you see my slide?
Looks good.
Okay, great, perfect. So yes, this talk is called DevOps, the Beginning of Infinity, and it's really me trying to look at, well, largely influenced by non-technical reading that I've been doing, but trying to understand our place in history and what our role in the DevOps space is. The book in question is by a professor Oxford University called David Deutsch, and he's a researcher into quantum physics. But he has a couple of, shall we say, popular science books that are extremely well written and have very big ideas in them. And the most recent one is called The Beginning of Infinity. It's from about 10 years ago. It's called Explanations That Transform the World. And his thesis is quite simple, but really far-reaching. And it's that all progress, both theoretical and practical, has resulted from a single human activity and what he calls the quest for good explanations. Good explanations is really the equivalent of knowledge generation for him. And when he talks about explanations, he says that there's many different areas, like how do we get to explanations? What is the engine that generates these explanations for us? And it's really the scientific method. It's the idea of conjecture and hypothesis, developing theories, bringing creativity to problems. But it's also the other side of it is testing these conjectures and theories and creativity against experiment and criticism, and understanding that we're fallible, that every hypothesis, every idea can be wrong, and using that information to perform some kind of error correction. And this is the kind of the engine of knowledge creation that we've built since the Enlightenment in the world. And what's quite interesting is that this is also very similar to what we find on the infinity loop in DevOps, where it's this idea that on the development side, what we're really trying to do is to creatively solve problems through creativity and coming up with, well, it's not theory and conjecture, but it's code and solutions, but it's the same thing. And on the other side, we have the real world, which is our users. It's our operations, it's our systems, it's the distributed world that we run our software in. And really what this DevOps loop is trying to do is form this kind of error correcting machine for growing the knowledge that is our software. Now, in the book, at the end of every chapter, David Deutsch comes up with several kind of different meanings for what he means the beginning of infinity encountered in this chapter. But at the basis, this idea is that we are at the beginning of, well, if we're on a journey to infinity, we're always at the beginning by definition. It just grows and grows, so we're always at the beginning. But the other interesting part of it is that it's kind of endless. The idea that we have progress that we can't see yet, but is inevitable. And this is, each of these chapters has lots of different ways that he defines this beginning of infinity. So the universal reach of explanations, the Enlightenment, evolution, the jump to universality, error correction, and computing. They're all just different ways or lenses to look at this concept of we're at the beginning of an infinity or an infinite process of knowledge creation, which is super exciting. So if I was to try and apply those ideas to DevOps, which I believe technology is part of this story around this knowledge creation and being at the beginning of infinity, and we're seeing this, we see it in Moore's law, we see it in lots of different areas. We are in a process of infinite knowledge creation. So some of the some of the earlier forms of this is, well, how are we doing in terms of progress, in terms of our delivering change or software change? And there's a great book, The Phoenix Project by Gene Kim and others. This was back in 2013, showing the deployment frequency for companies back in 2013. And you could see back then, Amazon was deploying 23,000 times a day. Facebook was once a day. Twitter was 3 times a week. And back then, the typical enterprise was once every 9 months. It would be an annual release almost. But what we see is over time that more and more companies are getting more and more frequent at delivering change. And I think you probably see this in Visma as well. The annual release is a thing of the past. It's, can we deploy today? Can we deploy this commit? And more of the industry is moving higher and higher up through this kind of rates of change. And this data is coming from the DevOps, the DORA research from Nicole Forsgren. But you see that they've even had to create new categories over time, like the elite category, to show that the elite, the highest performers, continue to get even higher performance as well. So it's not there's no end to this improvement. There's nobody that says, okay, we're now fast enough. We now deliver software fast enough. This is just going to continue to evolve. This is another example. It might be hard to read this. It's kind of hard to read on purpose. This is a long list of things. And what it is actually the number of AWS services the number of AWS services that Amazon provides. So you could say back in 2013, there was 30 odd individual services like S3, EC2, and so on that were provided by AWS. Now, in 2019, we're nearing 200. I don't know where we're at in 2022, but I'm sure it's more than 200. AWS as a company probably hasn't come to the conclusion that we have developed enough products and services to offer our market. And this is also something that is continuing to grow. The building blocks on which we make our software is continuing to grow over time. And that's the software as a service, or the platform as a service. But there's also the open source world, whereas the number of open source projects continues to explode as well. And the maturity of these projects are also taking huge leaps. This is the CNCF landscape from, I guess, 2015, something like this. And now we see it today. It's quite a bit bigger now, and there's more and more projects coming into the CNCF landscape. And this is just one area of open source under the Linux Foundation. Of course, we have the Continuous Delivery Foundation, we have the Linux Foundation, and there's lots and lots of work going on in building these reusable open components that we can all build our software on. And then, of course, we have other types of progress as well in terms of Infinity. So the manifesto for agile software development turned 20 years old last year. 4 very simple messages or values that it began with, and over time it grew to this beautiful thing called SAFE that I'm sure we're all super happy about. Now, of course, that's a joke. SAFE is something to be avoided at all costs, but you get the idea. And that brings us on to this idea that, not all progress is progress. We need error correction in our systems, in our knowledge generation as an industry. So what David Deutsch has to say about this is that without error correction, all information processing, and hence all knowledge creation, is necessarily bounded. You can't create more knowledge unless there's error correction. You end up in kind of knowledge dead ends. And error correction is also the beginning of infinity. Without error correction, we can't find and get new and better answers to the questions we have. So going back to SAFE, what is the error correction to that? Well, I mean, obviously there's quite a lot of pressure back into the software community against scaled agile, but this is a great example of another type of error correction where you bring, shall we say, comedy to the situation. Someone has made this website called Scaled Agile DevOps. It's fantastic. They've got a Scaled Agile DevOps maturity framework. It's at version 2.5. As it says, enterprise transformation without the risk of culture change, and you can get certified. I am certified. I'm a certified practitioner of Scaled Agile DevOps maturity. It cost me $20, and it was worth every penny. So in this world of error correction, what is it that makes a good explanation? So there's good explanations and bad explanations. When it comes to generating knowledge, we want to rely on good explanations because they're the ones that kind of are the foundation for the next part of the next knowledge we create. So good explanations are hard to vary. What that means is you can't explain you can't explain something in one way and explain the same thing in a different way. It has to be very hard to vary, otherwise it's not a good explanation. It also has to be testable. Not all explanations are testable when the explanations come, but they should be falsifiable in some way. The other thing that David Deutsch says is that good explanations have got reach beyond their initial application. So, for instance, as we find out about, like gravity is a great example. That Newton, he figured out gravity from the apple, but also that was the way the planets moved. Before that, we had kind of the idea that there was two different kinds of physics: the ones that applied on Earth and those that applied in the heavens. And what Newton realized was actually it's probably all the same thing. And the other thing is that good explanations are fallible. They're open to being wrong. It's not a god that's decided this is the explanation, or it's not a source of authority. It's not somebody with a credential that's decided this. They're fallible because the good explanations are fallible because if we say that our explanation is completely infallible, then we can't test it. And he also goes on to say that everything is achievable given the right knowledge. And this is actually the core context of the books. It's that problems are inevitable. No matter what we do, problems are inevitable. But also, no matter what happens, problems are soluble. And knowledge is the key to that. The knowledge generation is the key to this. And again, we use creativity, hypothesis, conjecture to come up with solutions. And as we create new solutions, new problems arise. And then we have to solve them with new solutions. So it's this endless tension or infinite tension between the solutions and new problems arising. That's why we're still solving software problems today. The software has been around for a long time, but there's still new problems to solve because solutions create new problems. So if we were to apply this in the world, the domain I'm most familiar with is the DevOps world. What is the kind of path to infinity that we've gone through? Well, the first part was in the beginning, we understood that, okay, we need to build systems. I mean, this was the initial part of computer science. This was the von Neumann architecture and so on. We have to build these systems that we can run our software on. And then we created a profession around managing these systems. It was called systems administration. It still is called systems administration. And systems administrators administer systems. But new problems arose. And that was, well, we got more and more systems. And the amount of work started to scale linearly with the number of systems. So we needed more and more people. And it had all the kind of side effects of manual error-prone work. But we developed new solutions for this. We created scripting, and we started to automate the creation and configuration of these systems. And so we've kind of gone through this loop, actually quite quickly through my career, where it started with, we would create init scripts for systems and use Bash and Python and other systems to build up the system. Then we realized, okay, we need a higher level solution to this. We need to, because we're starting to get configuration drift. Once we've created the system, it drifts away from what we expect. So folks in the open source world created Chef and Puppet, started to create configuration management tools. And then we understood, okay, well, that's great, but the level of the system isn't enough. We need to think beyond that, because now we're having fleets of servers, fleets of systems. So we need to solve for provisioning. We need to be able to do infrastructure as code. So we then created Terraform and CloudFormation. And then we realized, okay, but if we really want to go faster, we can't have the definition for the environment be separate from the application. If we need to update our dependencies, if we need to change our networking structure, if we need to do anything around the environment our software runs in, that should also be done as code as well. So we came up with Docker, and that provided a way for us to package and ship an application together with its dependencies and configuration. And we realized, okay, we needed a tool for managing all these Docker containers we're running, and Kubernetes came along, and so on and so forth till we get to serverless. And my point isn't that, like, as we get to Kubernetes and serverless, we're kind of reaching the plateau, we've solved our problems. The problems are going to continue to come, and we see this already, where we understand that actually running Kubernetes is a pain, and having your system being completely serverless loses a lot of your architectural structure. So there's more and more problems to solve as we go up through this infinity loop. But with each loop, we're building and building upon higher and higher and more powerful abstractions. That's the point. So the next step is, like, how do we get beyond point solutions to more universal solutions? And there's a lot said about that in the book, which is super interesting. For me, the part that David Deutsch talks the least about, which is the most interesting to me, is this idea of culture and infinity. So I'd like to talk a little bit about infinite cultures when it comes to technology organizations too. Mitch Hedberg was a great comedian, sadly no longer with us, but he had this great joke, which is, I like the escalator, man, because the escalator cannot break. It just becomes stairs. And for me, that's the same thing as your culture. Your culture is the thing that your company culture, your organization culture, your tech culture is the kind of the fallback for everything else that happens. When things go wrong, your culture is what supports the company and the people to continue and to solve problems. And what David Deutsch says is that static societies and static cultures are inherently unstable in the face of new problems. So if we want to have a successful society, successful culture, we need to be stable in the face of new problems. We need to accept there's going to be new problems and treat that as kind of part of everyday business for us. On a related note, Repenning and Sturman had this really great article. It's well, it's actually a paper from, I think it was in the 90s. It might be more recent than that, but they had this great title: "Nobody ever gets credit for fixing problems that never happened." And in this paper, they're basically looking at how do organizations create and sustain process improvement or continuous improvement, and how do companies fail at this as well. So they really were looking at, shall we say, manufacturing world and Toyota production systems and things like this, but it's just as applicable for us in the software world. And what they actually found was that there's kind of a tension between, in any organization, between working harder and working faster in the face of a gap in performance, whatever that gap might be. So if you say your backlog is growing faster than you're able to deliver features, you might hire more people. This is kind of the B1 loop, the time work harder. We're going to add more people, we're going to put more pressure to do work, and we're going to spend more time working. And you get trapped in this kind of inner loop. And what that means is that you never actually close or improve performance because you're always behind in your work. And this is a problem that grows by working harder. It doesn't shrink. And there's a trap there because in the short term, you think you're delivering more work, like the number of features goes up over the short term, for example. But what you'll find is that, again, the hysteresis will kick in. You'll start to get slower and slower and slower, and the machine will clog up. And what they found is that in companies that actually work smarter, which is the outer loop, what they do is they inject a pressure to improve capability. So there's an active pressure to improve capability, which then leads to more time spent on improvement. Now, you might think that would be the solution, but actually it's easy to give up at that stage because there's a big delay between spending the time on improvement and that translating to more capability. So it's really easy to give up and say, okay, we've wasted all this time on, I don't know, migrating to the cloud or whatever your favorite improvement is. But because it takes some time, it really does need a lot of belief and vision to sustain this loop. And what's really quite interesting about this whole model, in fact, is that the key thing, that the asset that's like increasing or decreasing in value is capability. It's not performance, it's capability. What are we able to do? And I think that this is an important part of what we need to learn in technology as well. It's not how many features, it's not anything to do with the work itself. It's about our capability to execute that's more important. And that's the thing we need to grow. And for my opinion, in knowledge work, that word capability could just as easily be written as applied knowledge. How much knowledge do we have, and how able are we to apply it to the world? So just as a kind of final point on this, I really recommend reading this paper if you ever get the chance. So if we go back to this idea of applied knowledge, what does that mean in the context of software? And if I take it back to my own company, what are we doing to try and solve for this? So on any given day, I could have a good day, I could have a bad day, I could be motivated, I could be tired. On any given problem, I could have strong skills in that domain area or that technology. I could have weak skills in that domain area or technology. And basically, this will vary over time in the type of work that comes through the pipe. Now, what we do in our team is something called ensemble programming. You might have heard it called mob programming as well, which is the idea is that we never work alone. Essentially, we work in groups of 3 or 5 or 6 or 2 or whatever, but we, as much as possible, unless we have a very good reason not to, we work together, because we have the strong belief that it's not about the amount of work in progress that's important, it's about the quality of decisions we make that's important. So what we find is that the more people we have in the group, the faster the knowledge shares amongst our people, and also the higher quality decision making we make, and the shorter time to good decisions we have. So rather than getting each individual's performance on any given task, you get the peak for every given task. So it might be something you might want to try. Another area where I think is quite interesting around culture is if we were to look at, we can go back to the SAFE example, where there's basically a template for folks to follow. And that's kind of, in the case of SAFE, it's tried to being disseminated across an industry, but a lot of companies try and do the same thing, have a central process for, or a central methodology for how teams deliver work. But if you look at the best performing companies in the world at technology, that doesn't really happen. There's obviously templates and easy on-ramps onto like good practices. But in general, in all the leading tech companies, teams can choose how they work. The other part of it that's super interesting to me is who leads these engineering projects. And this is something that I really believe is kind of the next frontier for us as a software industry, is like, how do we build tech leadership? Because there was an idea in the past that was a different discipline. And in some ways it is, but it's easier to teach a technologist how to lead projects than to teach a manager to understand technology. As technology gets more and more complicated and the talent required to deliver it requires more and more understanding, you're going to be more successful with very strong technical leadership. And I think that's the part of the industry we haven't really solved for in terms of career development. Yeah, and one final aspect of this infinite cultures is about how you define your company. I've worked in companies that said our people are our greatest asset, and I've seen lots of other companies say the same thing. And I fundamentally disagree with it, because it's got this idea that, well, there's a concept of ownership, that our staff are owned by the company, which isn't true in any legal sense of the word or any moral sense of the word. But also, I don't think it makes sense from the company's perspective either. I'm sure there might be something inside the minds of people that's the asset, but I think that's really missing the point. And for me, what I think companies should really focus on is not that the people are the asset, but the connections between people. The network is the most important and valuable part of the organization. How strong the connections between people are, and how much knowledge is shared, how much leadership is shared. That's all. It's about the edges of the graph rather than the nodes. And I think that that's an important cultural distinction to make in a company. So just kind of to sum things up, like another key aspect, or where David Deutsch is going with his book, the reason why I wrote it in the first place was that he really is optimistic about the future. He really does believe that we're on an infinite path to knowledge and progress, and that all problems are solvable, and we just need to generate the knowledge in order to solve them. So this is the principle of optimism. All evils are caused by insufficient knowledge. So if we could just only find the right knowledge to apply to a problem, we will do fine. So what can we do? Well, you could take Theodore Roosevelt's advice, I think, do what you can with what you have where you are. And this is kind of all we can do. There is only what we can do, but as long as we're doing something, it will help in the big picture. And Andy Grove has this great book, Only the Paranoid Survive. He was the CEO of Intel, and this book is about him transitioning the company from being in the memory business to being in the CPU business. Great management book. And he says, in technology, whatever can be done will be done. I mean, there is no limit to what we can do here. So must progress come to an end? Is there a plateau? Is there a limit to what we do? Is there a completion or a catastrophe, or is it unbounded? And I think the answer is the latter, and so does David Deutsch, since I'm stealing his words. So that was it. I just want to say thanks for your time. I'm happy to take some questions now, and yeah, and if it's interesting to talk to me about Merkely at any time, feel free to reach out, and be happy to talk more.
Very good. Thank you so much, Mike. Just as good as the first time I heard it. We have a couple of questions. You were talking about the difference between working harder and working smarter. And I was curious whether you would have any concrete examples to make that more tangible. Like, is there in your company or somewhere where you have seen where it would make sense to say, instead of focusing on X as a KPI or a metric, focus on Y instead?
Yeah, I mean, the one that I'm kind of have my heart closest to is the concept of we have more work to do than we can do. So the obvious thing to do is to hire more people, especially if there's budget. Like, let's hire more people. Then you've got two problems. You've got the wait time, and you've got the mythical man-month problem of actually onboarding people can suck even more of your resources. So that's a classic. The other, like the work smarter, could be like, okay, what are we doing? What could we stop doing? What doesn't need to be done? What can we say no to? And like, it's a really different approach, but and you kind of have to train yourself to sense, because it's so easy to get stuck into this hamster wheel, in a sense. Like, we just have to keep going and run faster, add more people, do more things. You think, okay, well, what initiatives could we stop? What customers don't we need to satisfy right now? What is important? What is strategically valuable? Is this long term or is this short term? Do we need to be short term or do we need to be long term? And yeah, it's mostly about that. And then the other part is the investment in increasing capability. So you could say, okay, we've got more things to do than we can do. Well, why Why can't we do more things? Is it that we're missing knowledge? Do we need training? Do we need exposure to different technologies? Is there a short-term cost that will give us a long-term win? Like, for instance, investing more in our CI/CD pipeline, or could monitoring and alerting reduce our on-call requirements? Things like this.
Great. Another question, for those who may not have been exposed to SAFe or the criticism against SAFe, could you elaborate a bit why it might be a healthy thing to be skeptical there?
Right. Yeah. I guess this is a work harder versus work smarter thing as well, I would argue. And so the background of SAFe is companies want to do, they want to be agile, like with small a agile. They want to be more responsive to customer needs. They want to deliver on a better cadence. They want to slice into smaller chunks. But there are organizations where they say, well, yes, but we're actually delivering a really big system. So say you're delivering the next version of Windows, as an example, where you've got many, many interconnecting parts that need to be organized and planned together, and you kind of delivering to a schedule together. So what you're doing is you're kind of hitching every wagon onto one train. And that's essentially what SAFe is trying to do, help companies like form a structure around that. And I think that that's useful if that's exactly the problem you have. But most companies that are adopting SAFe are not trying to solve for, we're going to deliver Windows 12. They're solving for, we have a lot of architectural dependencies that mean we have to release things together. They have a management structure that wants everybody to be aligned on some kind of big bang releases rather than individual incremental releases. Could we do microservices instead of a monolith? How can we use team topologies to better use Conway's law to architect our organization so we're less dependent on each other? So that's kind of my main beef against it. Most places where I've seen SAFe adopted should not be adopting SAFe, but solving other problems.
Very good. In my mind, I always picture, let's say 100 people trying to march together while, being arm locked with each other. And
Yeah,
then, if one person falls, then everyone else falls as well. And I think that's maybe not every organization that tries to adopt SAFe, but a lot of them seem to work that way because of all the dependencies that you make even more formal than what they were before, right? Okay, there was one more question. You said something like that it is easier to teach a tech person to lead rather than teaching a manager the technology. And the question is really, can you elaborate more a bit more about that?
Well, I mean, this is a very personal and highly controversial opinion, but I'll give it my best shot to defend. So I think a lot of the evils that we find, I'm not using the word evil in the real sense, but a lot of the kind of the bad outcomes we see in tech organizations is because there's a disconnect between what's actually happening and those that are organizing the work, because they don't have enough context, they don't understand what the real challenges are, and so on. So I think like from the CTO down into an organization is like a much more important structure than from the CEO down in a tech organization. And that's what you'll find in Silicon Valley as well. The product officer and the CTO, they're kind of they're expected to know everything, right? Then they need to be able to go down and talk to engineers at the keyboard and say, okay, what are you working on? What is it delivering? What is the problem? And be able to understand that context. It's not about how to apply budgets and resources and hiring. It is that stuff too. But I think like if you want to lead great technologists, you have to be a great technologist. It's my opinion. And I think that we're seeing more and more companies become technology organizations and struggling with kind of not legacy management, but business managers managing technology organizations, and I think that often fails.
Yeah, and one small factoid that supports your view. In our internal research that we have done in Visma, we found that R&D employees by far prefer to be led by managers with an analytical management style. And I think that kind of supports what you're saying there in a small way.
Yeah.
All right. I think that's the questions we have for today. So thanks to everyone who showed up, and thanks to you again, Mike, for showing up as well. I really enjoyed it.
Super. I mean, I've had a great time as well. Thanks. Anytime I get to talk. Maybe I like the sound of my own voice, but it was no. In seriousness, though, I really appreciate the time, and happy to talk again anytime. So thanks for the audience.
Awesome. All right. Thank you, Mike. Thanks, everyone. See you in the next Visma Talk.